Hey guys, it's Mrs. Cat again with another three levels diagram. This time we're going to be talking about volume. Now, this is going to be pretty short and sweet because we don't have a whole lot of info that we're going to put on this yet because we've got some investigating to do. But a lot of this is going to be hopefully prior knowledge and some stuff that you have learned in other science classes or even in math classes about volume, which is the amount of space that matter takes up. Helps if I've got my pencil. The amount of space matter takes up. Now, because of this, we're going to be talking in 3 dimensions, taking up space. So we're going to add that as our first thing in our macro level. Volume is 3D. Now I'm going to do my best to draw a 3-dimensional object. Maybe let's just go with a rectangular prism. I'm going to call it that and not a cube because I'm not confident in my ability to make this look even on all sides. Okay, so do your best. We've got 3 dimensions that we're going to label. We've got length, we've got width, and we've got height. Right? Maybe you want to show 3 dimensions by showing like a cylinder. Right? That's going to be 3-dimensional. Maybe we've got a sphere. Let's like pretend like I'm shading that so it looks 3D, right? So objects that are 3-dimensional, we can measure volume for. The way that we measure volume, we don't really know everything yet, but we do know that volume measurements and the units that are used are different depending on whether something is a solid or something is a liquid. So I just labeled length, width, and height, and I'm sure that most of you know that we can calculate volume from those things. I'm going to make this even more general than that. So in our symbolic space, let me change colors up here. Let's say that we're going to have a solid and we want to find or calculate the volume of that object. Okay, we can use an equation. And to make this more simple or simplified, I'm going to say this is going to be the base times the height. And this is the area of the base. Right? So if we're talking about that rectangular prism I just drew or that cube, that area of the base is going to be length times width. Okay, if we're talking about the cylinder, we're going to find the area of the circular base times the height. Okay, and if we're going to find the volume of a sphere, there is an equation for that. We could look that equation up and use that to find volume. Now, if we don't have something like a solid and we're talking about a liquid, we're going to want to probably measure that volume. And so what we're going to do is use a graduated cylinder. I'm going to do my best to draw this. Let's say it's got a little spout on it there. And it's got graduated marks on it. Okay, I'm going to try to fill in a liquid level here. Okay, we can measure it that way. All right. Now, depending on which of these 2 things we're looking at, as far as a solid volume calculation or a liquid volume measurement, it's going to change what our units are. Typically, we're going to use centimeters cubed when we're taking those measurements of the base and the height and multiplying them together in those 3 dimensions. If we are using a graduated cylinder to measure volume of liquid, we're going to measure that in milliliters. Now, moving on to particulate level, our volume at the particle level is going to depend on the space between particles. And so, as always, we're going to draw some particle diagrams. Okay, so let's see here. let's go blue particles. I'm going to draw two pictures and we're going to compare those. So I'm going to use these nice dark blue particles here. Okay, so notice I use the same color and same size for my particles. So at this point, we should understand that these particles are all representing the same type of matter. The difference here is the space between them. So I have the same type of particle, I have the same number of particles, so that means my first mass is going to be equal to my second mass. The difference here is the space between the particles, which means the volumes are different. So because the first picture has less space between the particles, that sample of matter takes up less space overall, making the volume of my second group of 4 particles larger because of the greater amount of space in between them. So this is a great start for our volume 3 levels diagram. Again, we're going to have a lot more to add on here after we do a little bit more work.